Hello guys, I hope you are doing well. Yesterday we have started a new research topic that is cloud robotic architecture, which is also known as smart cloud. I have shared the robotic architecture diagram also yesterday. This is the cloud robotic architecture, which is also known as smart cloud. That means the robot, that is the client. We can say robot is the client, can have access to the data stored on the cloud. And this smart cloud architecture is used for big and huge computational purposes. Understood? So I told you yesterday also that the cloud robotic architecture has two main components. The smart cloud architecture consists of robot layer, which consists of ROS based robots and non ROS based robots. Got it? And the cloud service layer. We use only JS libraries because these libraries are beneficial for the robots running on the ROS based system. Moreover, JS libraries are present everywhere. They are ubiquitous and the most widely used libraries over the internet. Got it? So here is the explanation of first layer, which is divided into two parts. Number one is robot layer. The robot layer consists of either single robot or a multi-robot system. Means a multi-robot system consists of so many robots connected in a single system. So this is known as multi-robot system, and in single robot only one robot is connected. That runs either on ROS, means the whether it is robot or multi-robot system, single or multiple, they runs on ROS, means robot operating system or any other software. Clear? Next is ROS based robots. So number one is ROS based robots and the another one is non ROS based robots. So the ROS based robots are used for writing robotic software. They are used for writing robotic software, and we have seen in the diagram that there is an ROS bridge which is between the ROS based robots and the cloud platform, and it allows the ROS based robots to interact with the non-ROS based system which is on the right. Means ROS system on the left is interacted with the non-ROS based system on the right through which part? Through WebSockets. Through WebSockets. Clear? Next, in this architecture, I told you that there is an ROS bridge which is used to establish, which is used to connect robots and the cloud service, because the cloud layer is in the middle and it is used, the bridge is used. Bridge. What is the purpose of a bridge? It is used for communication between the robots and the cloud layers. Means whatever the services the cloud is providing, the robots, the clients can access to those services. And on the cloud architecture, there is a master instance of ROS, which is called ROS instance, and it helps robots to offload the computations, whatever the tasks are being given to the robots, the tasks are given as an input signal to the clouds with the help of ROS instance. Clear? I hope you understood it. Now come to the next topic. We have robot layer. The robot layer, robots can access, I told you, it can access JS libraries, JavaScript libraries, because the robots can only work on ROS based software. So they need JS libraries which helps in robots ROS based systems, and the robots can access ROS packages also. So for using the ROS packages, robots need to run on robot operating system. Firstly, we need that the robot should be operated on ROS, and hence the cloud provide the corresponding ROS packages to the robots. So data in the form of input from the robot, because robot is providing the data, and is published on the cloud as ROS topics. What are called ROS topics, and they are received on the cloud side, means on the cloud platform they are received, and what type of communication is provided to them? ROS bridge is getting the communication and the cloud side is receiving the output. So with the help of the following code, the function ROS topics, variable topics client equal to new ROS lib library dot service. So this is the code. With the help of this code, the data is published as ROS topics and the cloud side, that means the cloud layer, is receiving those topics and do computations accordingly with the help of this code. Come to the next part, every ROS package. Okay, the ROS package is used to run the robots. So every robot operating system package takes topics only from the robots and the topics are entered in the form of input signal as I have told you. So it receives a list of topics. The cloud receives a list of topics, means there are so many topics for computational purposes and the ROS packages are given by the cloud with the help of these given inputs. Means input signals are given from the robots and the cloud provides the available ROS packages to find the computations of those inputs. Clear? Come to the next part. The matching of ROS packages means the whatever the robot is asking for the packages, the ROS packages are provided with the help of clouds and they are displayed on the web interface and the client, that means the robot, can choose where to work from. Clear? After the client, the user picks up an ROS package, the result is the output is done, the output is computed and it is sent back to the user, that means to the robot, with the help of ROS bridge. Clear? I hope you got the explanation how ROS packages helps in the robot for providing the output of the given corresponding input signal. Next we have second part, non-ROS based robots. So non-ROS based robots are not using, because as the name suggests, non-ROS means they are not using robot operating system. But what happens? How the data is transferred? So the data is directly transferred to the cloud with the help of wireless protocols. There is no need of ROS packages here. The data is ultimately transferred to the cloud using wireless protocols. And once the data is received, the ROS architecture means the cloud provides a JS libraries and the input signal is received and the corresponding output is given to the user after computations. So for example, one example is given here. I have written, if a message, let us suppose the input signal is in the form of a message, but the architecture provides libraries, like in the form of JS libraries, they provide the output, they provide the packages for object detection, because it is the input is in the form of the image. So the libraries are provided only which are related to for object detection, for tracking of the object and for liking the object. If the message is in the form of a GPS coordinates, then the cloud framework, cloud platform provides GPS based applications. Clear? That means according to the input, the libraries or the packages are provided. In case of ROS based robots, the packages are provided, ROS packages are provided. But in case of non-ROS based robots, directly the libraries or the GPS coordinates, GPS based applications are provided to the user. Clear? So on the server side, we have a RESTful based web service. What happens? A RESTful web-based service is provided. And what is the benefit of providing RESTful based service? It is used for communication and the results are given back to the robot. Clear? The RESTful based service are used to communicate and giving the results back to the robot. I hope you understood it. So web service basically provides communication between the client and the server. Client is the robot, server is the your smart cloud. So client, that means between the robot and between the smart cloud, the communication is provided, the medium is provided with the help of RESTful web service. So the communication is carried out with the help of one language. That means the output is given to the user, to the robot, with the help of one language, and the language is called XML, that is extensible markup language. So the robots are treated as the client, I told you many times, and the architecture is regarded as a server. So how does the robot send request to the architecture? In the form of HTTP. That means an IP ID is sent to the architecture, and the architecture respond according to the XML in the form of XML. That means extensible markup language. The output is given by the architecture in the form of extensible markup language. I hope you understood it. So our next part is smart cloud SaaS based ROS interface. So the robot provides a list of topics. That the list of topic means the input is provided to the architecture, and the architecture, what is the function of architecture? To display ROS based packages that can be used for the output generation. So this is the ID, and the smart cloud, as it is written, a cloud robotic architecture for heterogeneous multi-robot system. A robot's IP is given, and 102.108.1, 103.8088 an IP is given, and the list of topics are given on the robot, and these available topics are input signal. So the architecture opposite to the arrows, the output is given. So the available ROS packages are given by the architecture, and the output is generated according to these ROS packages. Understood? So this is the SaaS, that means software as a service based ROS interface, robot operating system interface. Next we have cloud layer. Second part, cloud layer. So robots are connected to the JS server, JavaScript server, with the help of WebSockets, I told you. So number one is JavaScript server. The JavaScript server are based on Node.js. What is Node.js? It is an open source platform, or a cross platform you can say, that runs only on JavaScripts outside a browser. Clear? And JavaScript server is used for handling both ROS, robot operating system, as well as non-robot operating systems. Then we have JavaScript libraries. I have told you that these libraries are generally used in smart cloud system. We have different kinds of libraries, such as standard libraries, Python libraries, C++, C libraries are also there. But this system, the smart cloud system, only uses JavaScript libraries because they are easily accessible and ubiquitous. They are present everywhere. And it is the most widely used libraries in web browsers. There are so many applications. They are used in web browsers, mobile applications, in gamings you can use these libraries, IoT, AI, ML, robotics, and so many industrial purposes, for agricultural purposes, in satellite communication. There are so many applications of JavaScript libraries. So because of this usage of JS, it is growing at a very fast pace, at a very fast speed. So what is the popular package manager for JS? That is Node Package Manager, NPM. And it is having 35,000 open source packages, more than 35,000 open source packages. I hope you understood it, the architecture of smart cloud system. So this is the complete architecture. You can innovate your research by taking help from this topic. So this is enough for today. Stay tuned to my YouTube channel. Thank you. Have a nice day. And don't forget to like, share and subscribe my YouTube channel. Thank you.